The Internet is a global network of physical hardware. It consists of thousands of miles of fiber optic cables connecting servers and routers across continents. The World Wide Web is a software application that runs on top of that physical cabling. Conceived at CERN by Tim Berners-Lee, it is a system of linked documents communicating over the network. Modern web architecture enforces a strict separation of concerns. Developers divide applications into three distinct layers: structural content, visual design, and logical processing. If we think of a web page like an automobile, HTML, hypertext markup language, forms the chassis and structural frame. CSS, cascading style sheets, provides the paint and interior design. JavaScript serves as the engine and electronic control unit, driving the interactive features. To understand how this functions, we will track a network request from the moment of keystroke to the final server response and decode the exact HTML skeleton returned to the browser. Mastering this client-server communication model is a prerequisite. Before writing a single line of interface code, you must understand the underlying rules dictating how data moves. The cycle begins when a user inputs a URL into their browser. A URL, or Uniform Resource Locator, is a human-readable address pointing to a specific web asset. The browser must translate that text into a machine-routable Internet Protocol, or IP address. It queries the Domain Name System, or DNS, a decentralized directory that maps the domain name to the exact numerical address of the target server. With the destination resolved, the client establishes a direct transmission connection to that specific application server. The browser then formats and sends an HTTP request. HTTP stands for Hypertext Transfer Protocol, the primary set of rules governing data exchange on the web. This request typically uses the GET method, asking the server to return a specific resource in its entirety. If the user were submitting new data, the browser would use the POST method instead. The server processes the request and replies with a 3-digit status code to indicate the result. Responses in the 100s provide informational updates, while codes in the 200s, like 200 OK, indicate a successful transaction. The 300 class indicates a redirect, telling the client to look at a different URL. Codes in the 400s represent a client-side error. This is where you find the standard 404 not found error, triggered when the browser requests a resource that does not exist. Finally, the 500 block flags an internal server failure, meaning the client sent a valid request, but the server crashed while trying to fulfill it. The web is not a state of continuous open connection. It operates as a series of isolated textual request and response handshakes, governed by these strict networking parameters. When a server responds with a 200 OK, it delivers its payload. This payload arrives at the client browser as a flat, linear stream of alphanumeric text characters. The browser's parsing engine engages, reading the HTML syntax, specifically opening and closing tags, and folds that flat text into a rigid, three-dimensional architectural hierarchy. Every web document begins with a doctype HTML declaration to define the file format, followed by a root HTML tag that wraps the entire page. Inside that root, the document splits. The head section contains invisible metadata and external links required for processing. The body section contains the actual rendered content the user sees. HTML is an engineering tool. Its primary function is not to paint visual designs on the screen, but to establish strict structural meaning and data relationships for the browser to execute. When developers build out a website's directory structure, they use relative paths to link multiple HTML files together without writing out full URLs. To link to a sibling file located in the exact same folder, the path simply calls the file name directly. To move down the tree into child subdirectories, the path declares the folder name followed by a / and then the file. To navigate backward up the directory tree into a parent folder, developers use a double dot notation. Once the browser parses the document, it applies default spatial rendering rules to populate the screen. Block-level elements, like headings and paragraphs, force a line break and automatically monopolize 100% of the available horizontal screen width. Inline elements behave differently. They only consume the exact pixel dimensions required to wrap their internal text, allowing multiple elements to sit side by side. To override this standard top-to-bottom flow and enforce specific grid geometry, developers use the table element to create complex nested structures. A table dictates a precise hierarchy. The parent table tag wraps individual row tags, which in turn wrap the distinct data cell tags. By applying the callspan attribute to a specific cell, developers can force that data point to stretch horizontally and merge across multiple columns. Similarly, the rowspan attribute forces a single data cell to merge vertically downward across multiple rows. Without external CSS styling applied, a website's spatial layout is entirely beholden to HTML's rigid geometric nesting rules. The HTTP protocol has a significant limitation. It is entirely stateless. The server forgets the client's existence the millisecond it delivers the requested response. The HTML form element is the engineering bridge used to circumvent this limitation. A form uses the action attribute to define the exact backend endpoint destination that will receive and process the client's data. The method attribute determines how that data travels. A post method securely hides the form's contents within the request body, rather than exposing it in the URL string. Inside the form, input widgets like text fields and checkboxes utilize name and value attributes to construct the exact key-value data pairs the server expects to read. Forms act as the critical engine of interactivity. They allow a static markup language to construct dynamic data payloads and push new state back upstream to the server. We can now see the entire macro cycle. It begins with the client's initial URL trigger and an outgoing GET request. That request clears DNS resolution and routes across the physical network via the HTTP transit layer. The destination server processes the query and returns a 200 OK status alongside a raw HTML text payload. The client browser unpacks that syntax, rendering the rigid blocks and inline elements onto the screen based on strict spatial rules. Finally, the user populates an on-screen form, triggering a return post request and closing the interactive loop. HTML and HTTP construct the structural chassis and the communication pipelines of the Internet. However, to build a modern application, this chassis now requires CSS to control spatial positioning and JavaScript to execute dynamic logic.